So for the oxidation, the dichromate will actually dichromate, as we have seen, it's stable in acidic medium, so its oxidation will actually occur in acidic medium. And it will be reduced to the +3 oxidation state, which is the most stable state for chromium, a +3 oxidation state. And what else shall we form? Shall form water. So we shall have water as well formed. So how are we balancing this equation? We can write this well. So how are we balancing this equation? We first raise some of these things here. Okay. So how are we balancing this equation? We can see that we have 2 chromium this side. We have to add a 2 to balance that. And then what of our oxygen? Oxygen this side has 7, and what of the right hand side? There must be a 7 added to balance it as well. But as we add the 7, we can see that we are affecting the total number of hydrogen atoms to 14. So we shall need to add 14 here. And eventually, we can now balance our charge. So what do we have as the total charge this side? We have a -2 plus 14, that is a +12. And then what of our right hand side? We have +6. So remember, we are going to balance borrowing electrons, and electrons are actually negatively charged. So meaning I have to add on a side that has more charge, you get? So I'll add the electrons to my left hand side so as to reduce it by how much? By 6. So meaning I have to add 6 electrons, you get? So that I reduce this charge by 6. So I'll add 6 electrons, and I'll have that equation well balanced. So I can put now my arrow. So for all oxidation reactions which you can practice, you'll find that this will be the half reaction for the dichromate involving dichromate ions. You can have it reacting with maybe iron 2 ions, I'll not give everything, but you can check out all the possible redox reactions involving the dichromate. I'll just give you the core idea behind these redox reactions and the points of emphasis. So this one will be oxidize, meaning for it has to reduce, which means it releases the electrons. So you can balance the total number of electrons. This side there are 6, so I have to have 6 even this side, meaning the whole equation I'll multiply it by a 6. Balance electrons. So after that, you can add the 2 equations and you have your electrons cancelling out, and you have the overall equation, which will have the dichromate plus 6 iron 2 ions plus 14 hydrogen ions, and that will form 2 chromium 3 ions, 6 iron 3 ions, and 7 water molecules, and that will be the equation. So this was just a by the way, but my point here is that I'm giving you the principle behind, and then you can go on to practice as many as you can. So what will be the color changes in case we have dichromate involved? This is an orange solution, and these are green in solution. So this will be a green solution. So whenever you have the dichromate reacting with maybe something else whose color does not fully cover the orange and green, this will be the color changes, you get. So you have orange turning to green, and that will be the reaction. Then the other way they can trick this is that they can tell you that to the chromate 6 add maybe hydrogen ions, and we know that the chromate 6 is not actually stable in acidic medium. So what will happen is that you have it being converted to dichromate. And after being converted to dichromate, they can tell you now to the resultant solution. Remember, there is this acid already, you get? So the solution will be acidic, which means it favors the reactions of the dichromate. So they can tell you that to the resultant solution, add this solution containing iron to ions and state the observation. So you must know all these color changes, that you have your yellow solution turning orange. And then from the orange, the reactions that follow, you know what happens, orange to green, or if there is a color that covers this orange, then you can see something else, as we shall see again. So for these reactions with normal reactions involving oxidation, that's what you have, but there is one exception, and that's a reaction with hydrogen peroxide. Hydrogen peroxide, we are going to see how unique it is. So we have this reaction with hydrogen peroxide. So unlike other chemicals that react with dichromate and chromate, hydrogen peroxide will be unique in that for it will form another product which is known as the chromium pentaoxide. So this will form what we call the chromium pentaoxide, and it's a blue in solution, However, we shall again see that this product form is actually unstable, you get. So normally in the lab they will tell you to add an organic solvent, any organic solvent you can think of, as long as it's immiscible with water, you get, miscible with water, you get. That will be the key idea behind, that you add this organic solvent and it will stabilize this compound so that it does not decompose. Because if you have it in solution and you don't add this organic solvent, you will have the blue again decomposing to give you the chromium 3 ions, which will appear green. So you have the blue now turning green. You will just know that the chromium pentoxide has now decomposed back to chromium 3 ions, and then you have oxygen gas as well given off. So that's if you don't add the organic solvents. But normally we shall have the organic solvent added in the lab. So let's look at how this reaction actually proceeds. So what will happen is that you have this dichromate, and what will happen is that instead of having the acidic medium, you will have rather water reacting with this. Where is the water coming from? It will come from the hydrogen peroxide, you get, or even in solution. And understand it your way, as long as you can remember the idea, the principle we are going to discuss. So you will have this dichromate and water, and what they will form is the chromium pentoxide. So you have this chromium pentoxide formed, and what else are we going to form? We are going to form hydrogen ions, you get. This is aqueous. Okay, can correct this aqueous. It will appear blue, and then you have your hydrogen ions formed as well. So you have hydrogen ions, hydrogen ions, aqueous. So let's balance this equation very fast. So what do we have? We have chromium 2 on this side, we shall put at 2, and this will directly affect the oxygen to 10. So we have to balance. This side we have how many oxygen atoms? We have 7 plus 1. So how do we make it 10? Can multiply here by 3. And that will directly affect the hydrogen atoms to 6. So we have a 6 and everything will be balanced except the charge. So we can balance the charge finally. So the charge, this side you have a negative 2 and this side you have a positive 6. So how do we make this equal? We introduce electrons. How many will make this side have a negative 2 as well? There will be a total of 8. You get? Meaning I have to subtract 8 from this side to have a negative 2. And also, for the chromate, if it's the chromate instead of dichromate, it will also form the chromium pentoxide. So you will have the chromate plus water, and then you'll have your chromium pentoxide formed. Okay, so you have chromium pentoxide formed, chromium pentoxide, and then what else? You have hydrogen ions. Even this one will give you hydrogen ions. So we can balance this chap chap. Chromium is balanced. Let's balance the oxygen. This side we have 4 plus 1, that's 5, and this side 5. What of the hydrogen atoms? Hydrogen 2, hydrogen 1, so we multiply this side by 2. And then eventually look at our charge. This side we have a negative 2, this side we have a positive 2, meaning we have to reduce this right hand side by 4 to make it negative 2. So we add 4 electrons. So that's the half reaction for the chromium. Then what of the hydrogen peroxide? So we'll have hydrogen peroxide. In this case, it's acting as an oxidizing agent. Why? Because it will be receiving these electrons that have been released from these two. So it will be acting as an oxidizing agent. So can have this hydrogen peroxide, and then you have hydrogen ions from here that will be released. Get and have hydrogen ions, and then what are you forming? You're forming water. Get, so you form your water, as the main product. So let's try balancing this. So we have hydrogen. Let's start with oxygen. It's the easiest. So we have 2 here, and we make this side 2 as well. And you can see that the total number of hydrogen atoms this side will be 4. And what of the left hand side? Need to multiply here by 2. But the charge will have changed to plus 2. So how do you balance this to become neutral? Add 2 electrons. You get? So these will be the half reactions for these two equations. I mean for our equation or reaction with the hydrogen peroxide. So what will happen if it's reacting with the dichromate ions? Could be from potassium dichromate or sodium dichromate. You just get this equation and then add it to this. But before doing so, you need first make sure that the number of electrons are equal in both equations, you get, and they must be on opposite sides. So you have the dichromate this side reacting with the the hydrogen peroxide, and then you have a total of 8 hydrogen ions. That's after multiplying by 4 to make them equal to 8. And then you have 8 hydrogen ions. What of this side you have? How many water molecules? Will the water molecules be on the right or on the left? It will depend on which one has more. Because if I multiply this side by a 4, I'll have 8. You get? So how do I balance this equation? Because I have water on either sides, I reduce this side by a 3, meaning water will be a product as well. The same will happen to hydrogen ions, which will be reduced by 6. So this 8, you reduce it by 6, and then you have it on the reactant side. I never wanted to write the equation, but let me write it so that you get to understand what I mean. So we can have our equation down here using the two equations. So we shall multiply, shall do it from here to save time. So multiply everything by 4 here, and we shall go on reducing. So we have, what are the reactants? We have dichromate, aqueous, and then of course this remaining as 8. We shall multiply this by 4 to make the electrons 8. So this remain the same. And we have 3 water molecules, and we have 2 chromium pentoxide plus 6 hydrogen ions, 6 hydrogen ions plus 8 electrons. And then the reaction for hydrogen peroxide, we shall need to multiply everything by 4, and we shall have 4 hydrogen peroxide aqueous plus 8. Okay, 8 because we are multiplying everything by 4. 8 hydrogen ions, and then plus 8 electrons, and this will be equal to, oh sorry, on the right hand side you shall have 8 water molecules. So we need to add these two equations in a balanced way. So let's first cancel out the common ones, which are electrons. What else? Hydrogen ions. We have 8 here, we have 6, so we reduce this side by 6 and we remain with 2 hydrogen ions, and this will go. What of the water molecules? We have 3 on the left, 8 on the right, so reduce by 3, and then this will change to 5 water molecules. So we can now have our overall equation down here after eliminating common compounds. So we have chromium, dichromate, plus 4 uh, hydrogen peroxide molecules, plus these 2 hydrogen ions. So plus 2 hydrogen ions plus 2 hydrogen ions. and this will yield two potassium pentoxide molecules. What else? We have 5 water molecules. 5 water molecules. Is there any other product? No, those are the only products. So what will be the observation? The observation is that the orange solution will turn blue. You get? Will turn blue. But if we add the organic solvent, let's say butane 1-ol, it will keep this solution blue. But if it's not added, you can go and tell the examiner that the blue solution will later turn green on standing. And the explanation will be that the chromium pentoxide disproportionate, or decomposes to chromium 3 ions and oxygen ions. So the green solution afterwards will be due to the chromium 3 ions that will have been formed. So you can try writing for the chromates and balance it as well. So the observation will be yellow to blue. If you have the organic solvent, it will remain blue. If it's not there, then you have decomposition to the green chromium 3 ions. And that's the redox reactions for these two compounds.